Welcome back. In the last video, we measured portfolio risk. We focused on measures like standard deviation, covariance, and correlation. If you think about it, standard deviation is the same number on both sides of the average. It looks at positive outcomes that differ from the average the same way as negative outcomes. For example, say we expect to make $10, but end up making $50. That is quite different than losing $50. Why does this matter? Most investors don't actually lose sleep over upside surprises. What keeps them up is the chance of falling below a number they can't afford to miss. That's what this video is about: shortfall risk and a tool called Roy's Safety First Criterion. By the end, you will be able to do three things: define shortfall risk, calculate the safety first ratio for a portfolio, and use Roy's criterion to pick the safest of several allocations along with the actual probability of falling short. This shows up constantly in real portfolio management. Think of a pension fund with liabilities due, or a retiree who needs a certain income. Anywhere there's a minimum return a client genuinely cannot afford to miss, this is the tool. It's also a clean, practical use of the normal distribution, so it's worth having that comfortable in your head too. So while this material sits in the quantitative section of the CFA Level 1, it also connects directly with the portfolio management topic. Let's start with the idea I want you to hold on to. Standard deviation treats a great year and a terrible year as symmetric risk. Shortfall risk only cares about one side. How likely are you to land below the line you drew in the sand? Shortfall risk is the chance that a portfolio's return or its value falls below some minimum acceptable level over some time horizon. Call that minimum level R sub L for threshold level. Roy's safety first criterion says, out of your choices, pick the portfolio that minimizes the probability of falling below R sub L. This all rests on one assumption worth naming. Returns need to be normally distributed or close enough to it. That's a real assumption, not a formality. But it's the standard one these problems make. And it's what lets a single number answer a probability question instead of needing an entire return history. Here's how you actually do that. Calculate something called the safety first ratio for each portfolio. It's the expected return minus the threshold divided by standard deviation. The portfolio with the highest safety first ratio is the safety first optimal one, the one least likely to disappoint. Memorize this formula, you'll use it exactly as written, every time. But don't memorize a threshold number. Derive R sub L fresh from whatever the question describes, because the exam will change the dollar amount and the time horizon on you, every single time. Let's look at an example. A client has a $500,000 portfolio. At year end, she wants to withdraw $40,000 without dipping into her original principal. So, what return does she actually need? 40,000 divided by 500,000 is 8%. Below an 8% return, she'd be eating into her principal. That's her threshold, R sub L. She's considering three allocations. Allocation A: expected return 22%, standard deviation 30%. Allocation B: expected return 12%, standard deviation 8%. Allocation C: expected return 15%, standard deviation 16%. Pause the video here and try to work out which one is safety first optimal. Subtract 8, then divide by standard deviation for each one. Allocation A, 22 minus 8 over 30 is 0.47. Allocation B, 12 minus 8 over 8 is 0.50. Allocation C, 15 minus 8 over 16 is 0.44. Allocation B has the highest ratio, so B is safety first optimal. Notice what just happened. Allocation A had almost double B's expected return, and it still lost because its standard deviation was almost quadruple B's. Once you're this many standard deviations away from your threshold, more expected return stops helping if it drags a much bigger standard deviation along with it. That's the whole point of the safety first ratio. It isn't asking which portfolio performs best on average. It's asking which one is least likely to let her down. One trap worth naming here, the denominator is standard deviation, not variance. Divide by variance by mistake, and every ratio comes out too small, and with numbers this close together, that can flip the ranking entirely. Now, how likely is that shortfall exactly? For the safety first optimal portfolio, the probability of falling below the threshold is normal, of negative the safety first ratio. For allocation B, that's normal of negative 0.5. Here's where people trip. Your calculator doesn't have a button for this. You need the cumulative normal table from the exam. Find 0.50 in the table, and you'll read off 0.6915. But that number answers a different question. The probability of being below positive 0.5 standard deviations. We want negative 0.5. Because the normal curve is symmetric, normal of negative x equals 1 minus normal of x. 1 minus 0.6915 is 0.3085. So, allocation B has roughly a 31% chance of falling short of that 8% threshold. Miss that negative sign and you'll report 69% instead of 31. That's the wrong answer, dressed up as a right one, because you looked up the mirror image of the number you actually needed. One more connection worth knowing. If R sub L happens to be the risk-free rate, instead of some client-specific number, the safety-first ratio has another name, the Sharpe ratio. So when you rank portfolios by Sharpe ratio, you are, without realizing it, ranking them by how unlikely they are to underperform cash. Same formula, same logic, different threshold. This same normal distribution machinery shows up again under a different name, value at risk, or VR. VR flips the question around. Instead of a probability, it asks for the dollar loss you could suffer at some confidence level over some time horizon. If a portfolio's 95% one-day VR is $200,000, there's roughly a 5% chance of losing at least that much in a single day. Different question, same machine underneath. Now pause the video and try one. A client has a $250,000 portfolio and wants to withdraw $25,000 at year-end without invading principal. Allocation D has an expected return of 17% and a standard deviation of 20%. Allocation E has an expected return of 13% and a standard deviation of 9%. Which one is safety first optimal, and what's its probability of falling short? First, the threshold. 25,000 over 250,000 is 10%. Allocation D, 17 minus 10 over 20 is 0.35. Allocation E, 13 minus 10 over 9 is 0.33. D wins narrowly. Its shortfall probability is normal of negative 0.35, which is 1 minus 0.6368. That's about 36%. So let's pull this together. Shortfall risk is the chance of falling below a minimum acceptable return, over some horizon. The safety first ratio is expected return, minus that threshold, divided by standard deviation. The highest safety first ratio wins, not the highest expected return and not the lowest standard deviation on their own. To get the actual probability of falling short, take normal of negative the ratio. And remember that negative sign is not optional. And when the threshold happens to be the risk-free rate, you've just derived the Sharpe ratio from a completely different direction. Next up, in quantitative methods, we leave formulas behind for a while. Simulation methods let the computer do the guessing and build a distribution of outcomes when there's no clean formula for the answer. Thanks for watching, and see you in the next video.